This conference will now be recorded.
In this video, we are going to learn how to use EDA Playground to run the Verilog and System Verilog simulations. So to use EDA Playground, please log into this website. First, you make sure that you are logged in. You can log in with your Google account. Okay. In my case, I'm already logged into Gmail. So once I log in as my Gmail ID, it automatically logs into EDA Playground. So when you open EDA Playground website, you will see two windows. This side is for developing the design code. This is for developing the test bench code. Here you can see it is a design.sv. Here it is testbench.sv as it suggests. So here we need to develop the RTL code. It could be in Verilog or VHDL or system Verilog. I mean, if you want instead of you need VHDL code, you need to develop a .vhd file. So right now I'm going to show you how to run the Verilog or system Verilog simulations. There are two ways to run the codes. Develop the code, gvim, then copy the code to EDA Playground website. Second is what? Develop the code on EDA Playground itself. There itself you can run and you can save the projects as well. Now let us see how to develop a code on GVim and copy the code to website. For example, I'll just pick one of my already existing design, interrupt controller.v. Let's page interrupt controller.v. So I'll go here, I'll select all this code. There is around 133 lines. Copy this, paste it here. So this asterisk symbol indicates that this file need to be saved. Once it'll ask you to, when you're saving, it'll ask you to use the valid tool or simulator. So there is this option where you can choose which simulator to use. So I go with Synopsys. Since I'm running system Verilog or Verilog, so I will not change this option. If you want some other language code to be compiled or simulated, you can choose correspondingly. Right now I'll choose this, and I'm not running any UVM simulations. I'll not pick any UVM version. Rest everything will be as it is. Now you go to the test bench, in select all. Typically when we run the simulations, okay, you again save this. Typically when we run the simulations, we would like to, majority of the times we would like to view the waveform. How to do that in EDA Playground? For that, what we need to do is we need to create VCD file. VCD stands for value change done. It is a system Verilog standard for saving uh, the signal value changes with, let's say we run simulation for 5 milliseconds. So my VCD will hold the values of all the signals for all that 5 milliseconds. So what is the value at 1 nanosecond? What is the value at second nanosecond? Let's say I have signals like ADDR, interrupt, data, write data, read data. I just took some hypothetical signals. So for all these signals, it will capture at each unit, at each step, what is the values of all these signals. So that is what my VCD file stores. Let's say if I take 5 milliseconds, it will consist of some lakhs of time steps. It typically each time step could be 1 nanosecond. Uh, so there would be such 5 million time steps will be there. So at each point, what is the value of address, what is the value of interrupt, W data, R data, it holds that values. So that format is what we call as VCD, value change dump. I mean, how does the value, where does the value changes? That those points it remembers. So hence we call it as value change dump. In simple terms, this is how we create waveforms in system Verilog, even in EDA playground. I mean, when you write system Verilog code, that's how we do. So you go, how to do that? Let's just understand here. You need to write initial begin dollar dump file. You need to specify which to which file this dumping should be done. So you're telling that test.vcd is the file which you want to do the signal waveform signal dumping. You need to do dump vars. If you just write dump vars, it'll dump all the signals. There could be multiple options where you could pass the arguments to it, which you can decide what hierarchy you want to dump the signals. Let's copy this code. Again, since you have changed the file, this will show asterisk what you are supposed to do. Go on, save it. Now both of them are saved. Only thing you have to do is, in my code, I would have included this because when I run it in Questa Simulator, it requires me to include the design.sv here. Right now it's not design.sv, it's not interpreter controller.sv, it is design.sv, which EDA playground I don't need to save it. Design.sv automatically gets included into this file. Now everything is saved. I can run it. So before running, since I want to view the waveforms, I need to click this option, open EP wave after run. You save it again. You see, you change some settings, it immediately changes. You save it. So its simulation runs. It gives you this symbol, use get signal button to add more signal to the waveform window. So what happens is when there are more signals, it doesn't add all of them automatically. Let's say, I think, I'm not sure how much is that count. If it is less than 10, probably it adds all the signals to waveform automatically. Whereas there are more signals, you have to manually do it. To do that, go to get signals. You choose from which one you want to add the signals, from TB or DUT. Let's say from the design and the test, that is DUT, I want to add the signal. It will show all the signals to you. You can select all of them, just up and down, close. Now you can go and see how signal values here. You can just move this thing. You can use this plus symbol. So you could see various entries. You could only difficulty there may be with this is moving this. Okay, probably helps you move. Yeah, this way you can move the signals. Let's say PR data, if you want to put all the APB signals at one place, you move it like this, move it down. PW data, you can move it. You can P enable. You can just probably select all the signals. Okay, it allows us to do only one signal at a time. So as you see in this part of it shows the APB. Sorry, I need to just color. Here you see the interrupt priority registers being configured. This is where interrupts are being serviced. First, second interrupt is being serviced. Next, fifth interrupt is being serviced. Next, zeroth interrupt being serviced. Because no, zeroth interrupt is being serviced. 2, 4 interrupts active. Okay, yeah. In between, we raise some more interrupts again. I mean, this video is not to explain what is interrupt controller. It is just to show you that whatever you could do through any other simulator, Questa Sim, VCS or NC Sim, all that analysis you could do with EDA playground itself. I mean, you can see everything, values being changed. You can minimize it. You can see the signal values, everything. It gives you a feel which is very close to the any other simulator. Only thing that probably you can't do in EDA playground is you cannot view the coverage. Other than that, you can do every other thing. So the most important thing in viewing signals is what? To add these 4 lines. Right now what happens is, because we haven't given any hierarchy, it dumps all the hierarchies. If you specify dump one, probably it dumps only one hierarchy, it doesn't dump the duty hierarchy. Let us just see this one. You run it. You say get signals, it only shows TB because you said only one hierarchy. It will only select the signals in one hierarchy. Again, how to do that? You go here, select all, just select this, append all. You can see the same code, right? Now if you want to dump the all the hierarchy, what you're supposed to do, you can, like, let's expand this. What do? You make it plus plus plus. If you want to minimize it, minus. So all the signals can be done. You can view in binary radix also, you can view in hexadecimal radix also. So all the things can be done. Let's say you want to move to, sorry, there must be an option where you can, using this, you can move in the window from this to next tab. I mean, this how you move in the waveform. Right. Minimize it. Again, you can go and change it to dump vars only. It will dump the complete hierarchy. Let's say if I give 2 means, it will give me both T and DUT now, because TB is first hierarchy, inside TB DUT is there, so that is a second hierarchy. So now if we go, it gives me DUT also, because it is first hierarchy, it is second hierarchy. I can go to DUT, I can add the same frequencies. So those signals are appended now. So this is for Verilog, right? We can do the same thing for system Verilog also. It wouldn't be any different. Close this. Now if I want to one second, save this playground, there must be an option to save these files. Okay. I'm just
This conference will now be recorded.
okay. Now let us see how to save our project. Save the project, whatever work you have done. What you need to do is you need to go to the share window. This all these steps have been explained in how to save this. I mean, you can go to EDA playground tutorial.html. That will explain you how to do all the things. Go to share. Now you say save. It will give you this link. You can use this link. Let's say I go to incognito window. I just paste here. It invokes this file for me. Let's say I add one more design file. For example, dff.v. Creating a file. Let's say you are creating a new file called as dff.v. Module dff clock reset dq input clock reset input d output red q module always under it positive edge clock begin end if reset q equal to 0 d. Again, since it is not saved, this will come. You just save it. Let us just see if same window holds. If I go to this window where I opened this thing, if I do control refresh, does it come? It comes. So it saves all my code by this keywords. Any change you do to this window will reflect. So we will try closing this browser and opening the same link again. Let's see if it works. So what we will do, we will copy this, copy to this one. We'll close it later. Right now, what we'll do, into the design.sv, include this file. I'm just going to instantiate the flip-flop because I just want to see how does this whole thing work in EDA playground. Call it as DFF dummy d flip-flop inst. That's all. No connections. Next, you are instantiating. Use oh sorry, here I can't do because I haven't logged in here. I just opened the window here, right? All the changes should be actually done in the actual browser. I should do. So here, just go and instantiate. Done it. Let's say I have clock reset. So reset itself I am passing as a flip-flop input. Let's say reset O, call it as. Here I'll declare fetch reset, y reset O. Just for understanding purpose. There is no logic in this why I'm doing this. It is just to see how to code new file, that new module, how to instantiate into the existing module. Now I can save this. I need to include this file. Include bff. I'm saving it now. Control S also you can use to save it. Now you just run it. One error. Token is D. Go to the DFF. in. Okay, here I did not put comma. It shows you this kind of errors also. It tells you ff.v token is d means you could see that I was missing comma, hence it gives the error. I have saved the file anyway. You run it again. Okay, now what I could see is I haven't added reset O, right? Now you go to this window, get signals. The DUT I have reset underscore O, right? You add reset underscore O, and I'll close and just go and check these two signals. Okay, reset is not coming properly. Let's understand why it's not coming. Make it 100%. It is coming as X because you're giving a floating reset value. Why that is coming as floating value? Let's see. Because my reset is not RST, it is P reset. The reset input is not RST, it is P reset type. So in the design.sv where I'm instantiating, I should be passing P reset type. Instead is P reset type. So reset. Clock is also clock type. There is nothing called as clock. I mean, how it works is automatically if there is no signal is not defined, it will take it as wire. Even though we didn't declare CLK and RST, tool inherently declares some as a wire, hence it doesn't give any error for us. Now you go and run it. It is giving me all the signals. So this signal you remove right now. And just place how it is happening. So the way reset was going low, wait, let's add P reset time. Okay. Now we need to debug why P reset I is not getting reflected on reset O. That is something let's not do it as part of this video because this video is just to understand how to use EDA Playground. It was just to show you that you could add multiple files. Let's say you could add one more file called as sample.sv. You create a file, just call it as class sample end class. You go to the, let's say you call method called as function print, white print function. You just call $display sample. Just a simple, that's all. You save it. You come to the test bench. You can include this sample.sv in the test bench. See, any new file you code, you need to include. But whereas design test bench and design.sv are concerned, you don't need to include them. So you come here, you include this, include sample.sv. Now what you can do is just instantiate it, sample as sinst. You can do new since it's object, initial, begin, end. Let's say sinst dot print. I'm just showing you how system Verilog class are also supported. How do you use them in simple terms? If you don't want to do it here, you code them as a separate GVim files and just copy paste the codes. Now you saved it, you run it. So somewhere I should get this message, sample print. So you could go up. Yeah, here it comes, sample print. So what you are getting, this log file is exactly what you would get in VCS version. If you run a VCS, this specific version 2014.10, what is the messages you would get is exactly that is what you are getting. Let's say one is this message, one is this message. So all these messages are exactly as they are getting, as you would get in EDA playground. In VCS tool, you are getting those things. Like this, you can choose multiple simulators, various other simulators, and you can run any of those. Now with this saved link, let us see if we are able to open this saved link. Let's close this. Let's close this browser also. So nothing is open now. I'm closing EDA playground browser also. I don't have any browser as such open. I can just can open my browser freshly. I can go here, saved thing. I'll just it, it loads the whatever project I have saved. So this is how you can save your projects. So how do you do that? By share and copying that link to save it. Now you can save this, share this to anyone and probably different social media platforms. Uh, this way, what is that we understand from here? You can develop multiple design files, multiple test bench files, and you can develop a complete test bench environment, a complex test bench environment using EDA playground. All that you will require is a, a decent access to internet. I mean, which allows you to code the files and which allows you to just run the simulator. That's all. Okay. So I hope this this has given you uh, an exposure to how to use EDA playground. I'll just right now what we have done, we have coded a new file. I mean, we have copied the existing files and ran that. Let us see how to do the new one. Let's go to one more. Just again start off with EDA playground. Okay, you will still be able to restore the old one. Let's say you again go and paste it here. We'll get previous project. Whatever interrupt controller run I have done, I will be able to get this one. Now I can share this to anyone. What does it mean? Any of you can just use this link x51eq and get access to this whatever code I have done. Right? It may be possible that I may remove these codes. So let's say I remove this code, save it. Here I won't be able to save it. Here I won't be able to save it because this in incognito window I'm not the owner of this link. I only have the link so that I can view this link. Why this could be useful? Let's say you have done some project, you want to share it to one of your friend who want to view the code or who want to debug, you want to take his help from debugging. Just share this link, they will be able to access this code whatever you have done. So here I won't be able to save, but here I can do that. I can do here whatever changes you do. If anyone opens those changes, let's say I add one more thing like a dummy comment, save it. You go here, someone does control R, refreshes, you'll see that same comment. Okay, now I'm going to show you how to develop a new code. It's pretty simple. Again, you take an up counter. I mean, you can here itself module counter, clock reset count module input clock reset output reg down to 0 count. Um, what do you do? Always at the rate of positive edge of clock begin end. What do you do here? If reset count equal to 0. I'm not using blocking non-blocking here, it just show you, and of course still use count plus 1 and save this. You choose a valid simulator again. Which one I will use? Let's say cadence I will choose this time. You save it, design is saved. Now you run so this is the new link file. I mean, you see this is different from 696E is different from 5YEQ. So this is the new project link that you can use. Now you can develop module test bench and module. You can instantiate counter as DUT, clock, reset, count. So since I'm using the same names, clock reset count, I need to declare them. I mean, respect of that, I need to declare the ports which I'm using to connect. Range clock reset, wire down to 0, count. Now you generate the clock, initial, begin, end. To generate the clock equal to 1, 0, forever. Let's say I'm generating a 100 megahertz clock. It will be nanosecond time period. So hash 5 is the low value or upper value for which duration clock will be either 0 or 1. So clock equal to inverse of clock. Next, initial, begin, end. You use reset equal to 1. You hold it for 2 clock cycles, repeat 2 at the rate of positive edge of clock. Then you make reset equal to 0. Then what you do is you wait for some 200 units, again apply reset equal to 1. After some 20 units, you make reset equal to 0. Again, for some 300 to 50 units, you hold, make reset equal to 1 after that. After 10 units, you make reset equal to 0, right? So this kind of coding you can just repeat. So this you now change it to, let's say, only 1 unit. This you change it to, let's say, 50 units. This you change it to, let's say, 8 units. I'm just running randomly. It behaves. Then after 100 units, you $finish. What I'm trying to do is, I'm trying to apply the reset to the count at different times to just to see how the count gets resetted. Save it. Now all the saves are happening to this. I can just copy this link again, go to the new browser, paste it here, same setup will come. I can run here as well. Okay, so to run, of course, it looks like I need to log into the EDA playground. So here you can just go on run it again. Okay, again, one thing what I'm missing, I will not be able to view the waveforms because I haven't done this OpenMP wave. Even to do this, I should create that VCD file. So how to create VCD file? Initial, begin, end, dollar dump file. Just write anything. For example, you write count.vcd, dollar dump vars. Let's say you want to save 2 hierarchies, you write dump vars 2. You save it. So it will open up the waveform to you automatically. You see this opening. Now you can move across the signals. Basically, you don't need this. There must be a way to delete this. That is this one. See, you don't need this. This is what? This signal is what? TB count 2 down to 0. Let's say you don't want TB signals, delete. This is what? TB DUT clock. TB DUT count. This is TB DUT reset. Now you can expand it and see how it is working. You see, at every edge of the clock, count is incrementing 0, 1, 2, 3, 7, 0, 1, 2, 3, 7. Whenever you reset it, whenever I'm applying reset, you see, count is getting resetted. Then again, as you do it, when it was 1, when you apply reset, it resets to 0. So this is how you can use the EDA playground. Really don't require a Questa simulator to do all the system verilog coding. Only when you need to do the functional coverage or code coverage analysis, you really require Questa Sim tool. Otherwise, you can pretty much manage this whole thing with EDA playground itself. And it is convenient because you can save hundreds of your designs into the just one website. You don't need to really have access to your laptop also. Just keep track of these things. So what do you say? This is for what? Counter example. This is what? Interrupt controller. So for now, what I'm going to do is I'm just going to read this thing. I earlier code. What is the first one? This one. Go here. I don't want it to be openly available because this is something institute proprietary. So I can just go and delete this code. Just go and delete this code. Now you save it. Nobody will be able to see. Only thing they will be able to see is dff.v. This will be empty. This will be there. This will be there. But my test bench will be empty. Whereas, of course, they will be still be able to see this 690 because I haven't done any changes. So I'll just keep this as it is. If you want to run this code, you can use this link. So I hope it has given you a good overview of how to use EDA Playground. I encourage you to use this EDA Playground a lot because when you go to interviews, when they conduct practical interviews, I mean where they give you a design or a test bench and ask you to develop the environment, they will not give you directly QuestaSim or VCS or NCSim simulators. They will just give you a browser. They will ask you to do all the coding on that browser itself. I mean, they will ask you to run everything on EDA Playground rather than on any other tool because it is a free source which can be used by anyone. Whereas to use QuestaSim, VCS, NCSim, we need to take the licenses, which itself is a very costly thing. Hence, companies when they conduct practical interviews where they want to check how good are you with practical aspects, they would do it through EDA Playground. Hence, you getting used to EDA Playground is a good thing. If you have any queries regarding this, you can always if you have any queries regarding EDA Playground, you can always approach me. I'm sure there are many other websites. Just go and say Google EDA Playground, how to use. You just probably use anything. You will get the various links. You can go through this. I'm sure there are multiple videos how to use this also. You can try any of those. Thank you.